Well, in nitrogen now, phenol, the product form depends on concentration of nitric acid. One is dilute HNO3 and then concentrated HNO3. And also depends on temperature. When the temperature is very low, means normal temperature, 298 Kelvin, you are getting ortho and para-nitrophenol. If it is concentrated HNO3, then the product formed is 2,4,6-trinitrophenol. Well, the question arises, is it possible to separate orthonitrophenol from para-nitrophenol? Answer is yes. This is because it depends on the boiling point of ortho and para-nitrophenol. As we are studied in PUC first year and also in the topic of phenol, there is a possibility of hydrogen bonding. Boiling point of phenol is much more compared to that of the hydrocarbons and haloalkenes and haloarenes due to intermolecular hydrogen bonding. But here, there is hydrogen bonding in this compound and also in the para compound. What type of hydrogen bonding? Well, in ortho product, we have intramolecular hydrogen bonding. We have intramolecular hydrogen bonding. And in para product, that is para-nitrophenol, we have intermolecular hydrogen bonding. What is the difference between intermolecular hydrogen bonding and intramolecular hydrogen bonding? So, in intermolecular hydrogen bonding, the association of molecule takes place. So, molecule get associates. For example, in para-nitrophenol, the molecule undergo association. We know when the molecule undergo association, we need more energy to separate these. That means the boiling point of the intermolecular hydrogen bonding compound or the derivative is greater than that of intramolecular hydrogen bonding. In intramolecular hydrogen bonding, simple, the hydrogen bonding takes place within the molecule. No association of molecule like this. Here, simple within the molecule. And it has very low boiling point compared to that of the para-nitro. And this one is steam volatile, it is non-steam volatile. Means we need more temperature, we cannot, on passing steam, you are not getting the vapors of para-nitrophenol, but here we are getting the vapors of orthonitrophenol because it's a steam volatile. There is a intermolecular hydrogen bonding. Here we have a intramolecular hydrogen bonding. So remember, we can separate it by a process called steam distillation method. Try to remember that you are studied in the previous first year. Passing a steam, volatile compounds comes out along with the vapors. So less volatile remain there. This one is less volatile, remain in the flask, but this one comes out along with the steam. So we can separate these two by that method. So this point is important. You may not have a question how they can be separated. That's ortho and para-nitrophenol can be separated in this examination. But maybe in competitive examination, which one is which method you are using to separate orthonitrophenol from para-nitrophenol? Answer is it's a steam volatile method. That's called steam distillation process. Well, next one. When phenol is treated concentrated HNO3, you are getting 2,4,6-trinitrophenol. It is also called picric acid. Well, this is the acid organic acid which do not contains carboxylic group. Here there is no carboxylic group. There is no COH group. But it's a strong acid. Why it's a strong acid? That you are studied in the effect of electron withdrawing group on the acidic strength of phenol. Nitrophenols are stronger acids compared to that of the phenol. Why nitro? These phenols are stronger acids because they withdraw the electron and makes the phenoxide ion more stable. When we have 3 electron withdrawing group, automatically it becomes strong. So remember this point. This is called the acid called picric acid without carboxylic acid. Well, after this, we have to study about the Riemann-Tiemann reaction and Kolb reaction, and then how to remove the phenolic group, and also what is the oxidation product of phenol. Well, now it is Riemann-Tiemann reaction. This reaction is important from the point of examination. All these are important. You can expect 7 marks from the topic oxygen compound part 1, organic compound containing oxygen part 1, that's alcohols, phenols and ethers. Well, it is Riemann-Tiemann reaction. Riemann-Tiemann reaction. Riemann-Tiemann reaction. So statement is phenol when heated with chloroform and NaOH. NaOH means sodium hydroxide, sodium salt of salicylaldehyde, sodium salt of salicylaldehyde is formed which on acidification gives salicylic acid, which on acidification gives salicylic acid. Well, we can write the equation for this. Phenol at first react with NaOH because we know phenol is acid. NaOH is strong base, or it's also called alkali. Product is sodium phenoxide. So here salt, sodium phenoxide is formed because reaction of acid with base gives the salt. Minus H2, elimination of H2 takes place. Instead of writing plus H2, I am writing below the arrow mark minus H2 means we have the product H2 here as taken on left side instead of writing on the right side. Now interact with chloroform. Remember the formula of chloroform, CHCl3. The product is ONA, then CHCl2. So we can write again the hydrolysis of the intermediate compound ONA CHCl2 undergoes hydrolysis with NaOH. The product is a dihydroxy compound is unstable because we have two OH, bulky, large OH group on the one carbon atom or on the same carbon atom, so it becomes unstable. It undergoes dissociation, that is, it splits, elimination of H2 takes place from OH to OH group, and you are getting sodium salicylaldehyde. Sodium salicylaldehyde. So sodium salicylaldehyde on acidification, you may write H plus or you may write, sorry, this is CHO. You may write H plus or you may write HCl. So acidification is represented as H plus. You are getting salicylaldehyde. Product is salicylaldehyde. This is the reaction. So phenol when heated with chloroform and with sodium salt of salicylaldehyde is formed, or you may say sodium salicylaldehyde is formed, which on acidification gives salicylic, which on acidification gives salicylaldehyde. Salicylaldehyde. Well, instead of chloroform, carbon tetrachloride is used. Then the product formed is now salicylaldehyde is salicylic acid. So instead of chloroform, carbon tetrachloride is used. Then product formed is salicylic acid. Instead of chloroform, CCl4 is used. Then product formed is salicylic acid. Salicylic acid. So it is called Riemann-Tiemann reaction. You may get salicylaldehyde or salicylic acid, after all it depends on the what type of reactant you are using. CHCl3, salicylaldehyde. If it is CCl4, product is salicylic acid. Well, after this reaction is important from point of examination. Now the next reaction is Phenols reaction. It's also called sometimes Kolbe's or Kolb's reaction. So in Kolbe's or Kolb's reaction, salicylic acid is formed when carbon dioxide, dry carbon dioxide gas is passed into sodium phenoxide at about 135 degrees Celsius. Under pressure of 6 to 7 atmosphere, sodium salt of salicylic acid is formed, that is disodium salicylate, so monosodium salicylate is formed, which on acidification gives salicylic acid. So Kolbe's reaction, when disodium phenate or phenoxide, sodium phenoxide, when dry sodium phenoxide is also called sodium phenate, don't get confused here. When dry sodium phenoxide is heated with CO2 gas to about 135 degrees Celsius under pressure of 6 to 7 atmosphere, sodium salicylic acid, that is monosodium salicylic acid, monosodium salt of salicylic acid or monosodium salicylate is formed, which on acidification gives salicylic acid. So you can write equation. Sodium penoxide, we know sodium penoxide is formed by reaction of phenol with NaOH. The product is sodium penoxide or sodium phenate. So in the sodium penoxide, when the sodium penoxide is heated CO2, you are getting this product monosodium salicylate. So monosodium salicylate on acidification will get salicylic acid. Product is salicylic acid or orthohydroxy phenol. So this reaction is also important. Both whole-based reaction and also Ringman-Niemann reactions are important. Well, after this, we have reaction of phenol with Zn. So when phenol is heated with zinc dust or Zn, you are getting benzene. Benzene is formed when phenol is heated with Zn. So this reaction is nothing but removal of phenolic group. To name the reagent used to remove the phenolic group means it is Zn. Just by heating with zinc dust or zinc powder, elimination of phenolic group takes place. Writing the reactants and products are important. So it's OH, phenol, then we have Zn. So this on heating, the product formed is benzene plus Zn2 is benzene. So after this, oxidation of phenol. Oxidation of phenol. Phenol undergo oxidation with acidified potassium dichromate K2Cr27 to give benzoquinone. Remember, it's not benzoquinone. Benzoquinone, it is not this aromatic compound. So we have the oxygen. It loses the aromatic character. So we have two oxygen at the ortho and at the para positions or ortho positions. So getting a mixture of benzoquinones. Phenol, just treating with the acidified K2Cr27 undergo oxidation. K2Cr27 in acid medium. Generally you are using sulfuric acid as the acidic medium. So acidified potassium dichromate. The product is double bond O, double bond O. So this one is benzoquinone. Benzoquinone is the product. Well, it undergo oxidation with K2Cr27. It's a brown in color. It's a brown color. Brown color. Even the brown color of phenol, when it's exposed to air, is due to the formation of the mixture of products. Phenol interact with the air, it undergo oxidation to give a mixture of phenols. It is orthophenols and also the paraphenols. So due to this oxidation, it changes to brown in color. That means phenol undergoes oxidation with the air. It also undergoes oxidation with air to give the phenol. Phenol also undergo oxidation. Phenol also undergo oxidation with air or in air, oxidation in air to give benzophenol. That's why the color of phenol changes to brown when exposed to air. So question is, phenol undergo oxidation by air, that's O2, to give the product phenol. This is the brown in color. So this is about the properties of phenols. What are the uses of phenols? Why you have to study these chemicals? This is because we have some applications of these compounds. For example, phenol is used as disinfectant. It's also used as antiseptic. Some medicated soap contains phenol. It's used as a disinfectant. And second, phenol is also used in the manufacture of salicylic acid. As we know, salicylic acid is used in the preparation of aspirin. It's used for the heart disease and it's used as a blood thinner. That's one of the main applications of aspirin. But the problem is, aspirin when undergo hydrolysis in our stomach, it produces salicylic acid and acetic acid. Both are strong acid and there is a possibility of bleeding in the stomach. And hence, only under the prescription of doctor, we have to use the aspirin tablets. It's also used in the manufacture of cyclohexanol, which is used as solvent. One of the main applications of phenol as a disinfectant in the preparation of aspirin, and also it is used as antiseptic. Well, in the topic of phenol, the important points are how the phenols are prepared. Second, it is why the boiling point of phenols are greater than that of hydrocarbons and haloalkanes and haloarenes of comparable molecular mass. And afterwards, next solubility of phenols, and then in chemical properties, it is cleavage of OH bond. In that you have studied the acidic property. It forms a salt with NaOH. That's one of the characteristics of the acids. Acid react with the base or alkali to form salt. Phenol also react with NaOH to form salt. Then we have studied esterification. Esterification can be done by using this carboxylic acid in presence of H2SO4 or by acetylation or by using acetate anhydride. And afterwards, we are studied about the electrophilic substitution reaction. There you are getting the two types of product for bromination as well as for the nitration. In bromination, it depends on the solvent, what type of solvent you are using. So the product form depends on what type of solvent you are using during bromination. If the aqueous medium is used, for example, if bromine water is used, then you are getting white precipitate of 2,4,6 tribromophenol, and it is one of the test for phenol. Next, so if you are using bromine in carbon disulfide or carbon tetrachloride, it's a non-polar solvent, then you are getting orthobromophenol and parabromophenol. If you are using nitric acid, here also depends on the conditions. If dilute HNO3 at normal temperature, the product are ortho and para. If it is concentrated HNO3, the product is picric acid or 2,4,6 trinitrophenol. Well, here what you have to remember is how these ortho and para nitrophenols can be separated. So they can be separated by steam distillation method because orthonitrophenol is steam volatile. Why it's a steam volatile? Due to its intramolecular hydrogen bonding, that is hydrogen bonding takes place within the orthonitrophenol. In case of paranitrophenol, the association takes place because of the NO2 group and OH groups are in exactly opposite direction. There is no possibility of interaction of OH group with the NO2. So within the molecule, but when the NO2 group can join to the OH group of another phenol molecule through the hydrogen bonding, as we know it is called intermolecular hydrogen bonding. So association of molecule takes place and it has a higher boiling point, it is non-steam volatile. In that way we can separate the orthonitrophenol from the paranitrophenol. And then picric acid. This is the organic acid without COH group. As we know, we are representing the carboxylic acid or organic acid as RCOH. That means there must be a carboxylic group. Such a compounds are called carboxylic acid or organic acids. Well, picric acid is an organic acid without COH group. It is more acidic compared to other nitrophenols. It is due to the presence of 3 NO2 group, strong electron withdrawing group. We have totally 3 NO2 group and the acidic strength is much greater compared to ortho and para nitrophenols. You can compare, there may be a question in the competitive examination, compare the acidic strength of trinitrophenol, dinitrophenol, paranitrophenol, orthonitrophenol and metanitrophenol. So what you have to remember, on what position that NO2 group is present, whether it's on ortho or para, how many NO2 group are there, that also important. So number of NO2 group greater means electronegative groups are greater and acidic strength is more. This point you have to remember in phenol. And afterwards we are studied pole-based reaction and Riemann-Tiemann reaction. In a Riemann-Tiemann reaction, remember the reactants. It's a fluoroform and NaOH, then followed by acidification gives salicylaldehyde. So you practice it. It is difficult to remember the formula of all these things. You practice many times, you repeat it many times. Without only, usually what students is to do is simply they have to study and simply they are trying to remember. No, that's not the way of study. You have to write it and afterwards see where you are doing a mistakes. Then only you will be perfect. Otherwise, simply reading cannot use the idea about your writing the answer for the given question. So practice it. You have to write it. Then only you will be confirmed whether you have done a correct or wrong. And after that, this about pole-based reaction. In pole-based reaction, you are getting the carboxylic acid, that is salicylic acid, by treating sodium phenoxide with carbon dioxide, then a reaction with phenol. Phenolic group can be remembered, you have to remember this point, phenolic group can be phenolic group can be removed by using Zn. So we can convert this into this benzoic acid by heating with Zn. That means only remove the OH group, which one? Zn, just by heating. And then oxidation of phenol, you are getting benzoquinones. These are not aromatic. You have to remember we have 2 oxygen linked in opposite direction in the benzoquinone, that is para-benzoquinone.